All right, today we're in section 10.3, triangles. We're on page 484 in our books. You will need your books for today's lesson to do some practice problems. All right, the first thing you need to know is what are the basics of a triangle? This kind of seems like a little elementary, but you do need especially to know the first one. The angles of a triangle add up to what? 180 degrees. 180 degrees. So we're going to use that information to find the measures of unknown angles of triangles. All right, and then a triangle has exactly how many sides? Three. Can't have four, can't have two, it has to have three. All right, so three sides make up a triangle. Okay, so in example 1, we're finding an angle measure, the unknown angle measure in a triangle. We're always going to solve these by first setting up an equation. We know that the three angles of a triangle add up to be 180 degrees. That's how we generally set up our equations, okay? So all three angles added together will give us 180 degrees. Go ahead and write this equation in your notes. X. You don't have to write the degree signs in your equation, but you do have to have it in your answer. So x plus 83 plus 26 equals 180. All right, so is there anything that we could simplify or combine on the left side of this equation? What can we simplify? 83 plus 26. And what is 83 plus 26? So I want you to rewrite it now with your angle measure simplified, okay? So you're going to rewrite it again. This is step 2. All right, this is exactly how I want you to do your homework. Now, how do I solve for x? Subtract 109 from both sides. Yes, I want you to show this step. And yes, you can use your calculator to find your answer. X equals 71 degrees. Don't forget your degree sign in your answer. That's like your label. X equals 71 degrees. All right, so now I want you to work your turn now. Number 1 on page 485. Your turn now, number 1 on page 485. Number 1. Set up an equation. Don't just write the answer. Do you hear me? Setting up the equation is just as important as finding the correct answer. So set up your equation and then solve for the unknown angle measure. Okay, so what's my equation? X plus 43 plus 79 equals 180. What do I do next?
43 and 79.
Very good. What do you get?
122.
X plus 122 equals 180. Now what do you do?
Subtract 122 on both sides.
Very good. 122 and X equals?
58
Degrees. Degrees. All right, who got it right? X equals 58 degrees. Good job. All right, so that's it for example 1. Now in example 2, we're now trying to find the measure of an exterior angle. I want you to go ahead and draw this triangle in your notes, please. All right, what does this little box mean? That it's a right angle. So if it's a right angle, what's its measure?
90.
It's going to be 90 degrees. And your notes won't say that it's 90. Fix it. They won't say that it's 90, but we know that it's 90 because it's a right angle. All right, so I know that the top angle measures 55 degrees. And my bottom right angle measures 35 degrees. But now here's the angle that I don't know. This is what I call an exterior angle. It's not an angle that's inside the triangle. It's outside the triangle. So how do I find the measure of an exterior angle? Well, I'm going to focus on the interior angle that is connected to the exterior angle. And these two angles lie on a what?
Straight line.
They lie on a straight line. Do I know the measurement of a straight line?
180.
It's 180 degrees. So I would say that these two angles are what? Starts with an S. Supplementary. They're supplementary. So if I know that they total to be 180, can I set up an equation?
Yes.
180 equals y plus 35. Because I know that the sum of those two angles is going to give me 180. Does that make sense?
Yes.
Okay, so there I've got my equation, and now I can just solve it. All right, go ahead and solve the equation, please.
Subtract.
Yep, subtract 35 from both sides, and y equals what?
45 degrees.
Y equals 145 degrees. You think you can do one start to finish? All right, turn in your books to page 485. You should already be there. Do number 2, your turn now. Number 2. Number 2, your turn now. Set up an equation and then solve. All right, so what's my equation? Y plus 34 equals 180. The two angles, okay, that lie on that line, they're supplementary. So now I subtract 34 from both sides. And what's my answer?
146 degrees.
Y equals 146. And don't forget your degree sign. All right, who got it right? 146 degrees. All right, now in example 3, we're going to start classifying the triangles. I want you to now go ahead and mentally form 2 categories. Classifying by angles and classifying by sides. And do not mix them together, okay? That's probably one of the common mistakes that I see is people get their side classification confused with angles and they start to mix them. So 2 separate categories. When I'm classifying by angle measures, here are my 3 categories. It can either be acute, obtuse, or right. And that all depends on the angle measures. So guess what? If it's acute, all the angles are going to be less than what? 90 degrees. So this is just an example. All right? It could be a lot of different things, but it could be 70, 60, and 50. Are all 3 of these less than 90?
Yes.
Yeah. But they all add up to 180. Okay, so for an obtuse triangle, guess what? I'm going to have one angle that's greater than 90 degrees. An obtuse angle. And then the other 2 will just be less than 90. 38 and 34. Again, these are just samples, examples. All right, so they can be all different kinds of measures. All right, these are just some examples. What do you think a right triangle is going to have?
90 degrees.
A 90-degree angle. Okay, and then the other 2, well, yeah, will just be whatever. But it'll definitely always add up to be 180 degrees. Now, I didn't write 90, but how do I know it's 90?
Because the little square.
Because the little box. The little box. All right, do you think you can identify some?
Yes.
All right, so this is how it's going to look on your homework, quiz, and test. I'm going to give you angle measures. All of these are going to add up to 180, obviously, but I want you to tell me what kind of a triangle is it based on its angle measures. So what are our 3 choices? Acute, obtuse, and right. Okay, you don't have to write down the angle measures. I just want you to answer numbers 1 through 5. What kind of triangle do I have? All right, everybody together. Number 1. Obtuse. Why? Which angle? 115. 115 is greater than 90. What about number 2?
Acute.
What about number 3?
Right.
Number 4?
Acute.
And number 5?
Acute.
All right, very good. Who got all 5? Okay, last example. Example 4 deals with classifying triangles by their what? By their side lengths. Okay, so now separate category. I've got angle, classifying by angles, so that would be acute, obtuse, and right. Now I'm classifying by sides. That is equilateral, scalene, and isosceles. This is what it means. Okay, an equilateral triangle will have all sides equal. So 9 millimeters, and again, this is just an example. 9 millimeters, and guess what? 9 millimeters. Here's the rule for equilateral. All sides must be the same measure. Okay? With isosceles, only 2 sides will be the same measure. The third side will be different. I don't have much room under there. All right, the third side will be different. So 7, 7, and 8.
Pretty simple.
Then with scaling, guess what? They're all going to be different. So I might have this one's 3, this one's 5, and this one's 7 centimeters. Okay, so scaling, all sides are different. Now let me ask you this question. Can an equilateral triangle also be an isosceles triangle?
No.
Well, what's my definition of isosceles? How many sides has to be equal?
2.
Does an equilateral triangle have 2 equal sides? Yes. So an equilateral triangle is also an isosceles triangle because it has 2 equal sides. In fact, it has 3. Okay? But let me ask you this. Can isosceles be equilateral?
No.
No, because
It only has 2.
it only has 2 equal sides. So it doesn't go both ways. You need to know, and you might want to write it in your notes if that confused you. You need to know that an equilateral triangle can also be classified as isosceles. Why? Because it has 2 equal sides. That's the definition of isosceles.
You can't only have 2.
Okay? Equilateral, in fact, has 3, but it still has 2. Okay? All right, so classifying by side lengths. All right, guys, so let's classify these 3 triangles based on their side lengths.
I'm not done.
Okay. All right, I'll give you a couple more seconds. You don't have to write down the problem, just classify it. Just classify it by its side length. All right, number 1. What's number 1?
Isosceles.
Isosceles. You got to spell it right. Number 2.
Equilateral or isosceles.
Equilateral
I just found an earring.
Or isosceles.
or isosceles.
Or isosceles.
And then number 3,
Scaling.
scaling. Okay, you got them all. All right, last but not least, turn to page 486. I want you to do numbers 3 through 8. Your turn now, real quick. Number 3, what's number 3? Acute. Everybody together. Number 4?
Obtuse.
Number 5?
Right.
Number 6?
Isosceles.
Okay, number 6 would be only isosceles. It is not equilateral because it doesn't have all 3 equal. Number 7, scaling. And number 8,
Equilateral or isosceles.
and isosceles. And, not or, and isosceles. Okay? There is a difference. It's both. It's not either or, it's both. All right, if you understand that, that's everything you need to know for 10.3.